Good evening, all of you, and welcome in this session on MATLAB tutorial series 2023. Today, we are going to cover very important agenda, and in this agenda, we will cover various type of topics related to functions. As you know, functions play very important role to study various type of scientific computing, and there are some inbuilt functions in the MATLAB, but I have an issue. Yes. So there are two types of functions. One type are inbuilt functions in the MATLAB, and sometimes when the functions are not inbuilt in the MATLAB, in that case we have to write our own function. So in that case, there are several type of functions in the MATLAB. We can create global variable functions, nested function, primary and sub functions, private functions, and there is anonymous function also. So in the present session, we will try to cover all these topics, and these topics are very important to all of you, to how we can write this type of functions, how we can use them, how we can call them for different type of programs when we need to required to write this type of functions. So good evening once again all the participants who are joining this session, and hopefully after some time there will be more participants, and some participants are also waiting for us. In the last 3 lectures we cover various type of topics. Matrices is there, and plotting 2D and 3D both we have covered. And in the very first topic, we covered the basic fundamentals of the MATLAB. So the topic which we are going to cover is function. What is function? Function is just a group of statements that together perform a task. In MATLAB, functions are defined in a separate file. The name of the file and of the function should be the same. Functions separate on a variable within their own workspace, also called the local workspace, and separate from the workspace you access at the MATLAB command prompt, which is called base workspace. So first thing is we need to show what are the syntax to create a new function which is not available or provided in the MATLAB itself. Just you need to understand the syntax to write the program, and then it will be easy to implement. And there is several types also we are going to discuss, and I hope this will be very sportive lecture to all of you. See here, this is the structure to write the function, and we will follow all these rules. This is the very first line, as you can see at the top. At the very first, as you see, when we start to write the program in the MATLAB, this is the function. And the word function must be the first word and must be typed in the lowercase. All the letters must be in the lowercase. Then this part, this is the very important, which is the list of output arguments inside the bracket. and all the output argument will be separated with comma. Then this part is the function name. Okay, at this place we give the name of the function for our program which we want to write here. And function always involves some input arguments, one variable, two variable, three variable, and there are several multiple variables, as well as there are some type of parameters also. So all the input arguments will be at this place. So this is the list of input argument typed inside in the parentheses, and this is the name of the function. Okay, suppose I have y is equal to fx. I am taking here a very simple function at this place. So this is the output. So this will be at this place. And this is the name of the function. We can give any name. Suppose I am giving here fun. And this is the input argument. Okay, this will be at this place. So in this way, and after that, this is the very first line, and then after we have a body of the function. See at this place. See here. This is a very interesting example here. You can see. Yes. So here we write a function for, this is the function for loan function. Okay. So in the very first statement, as you can see, this is the function. This is the function. And there are two types of output. One is monthly pay. This is the monthly pay, and this is the total pay. This is the name of the function, as we are going to create a function for loan. And there are three arguments are required, three inputs are there. One is amount, second is rate of interest, and third is years, number of years. So this very first line is definition line. After that, this part. In this part, the very first line, what we are going to perform in this program, we will expand about that. So this is the on the very first line, loan calculate monthly and the total payment of loan. Okay, so these two calculations will be calculated in this program. Okay, so this is the H line. This line is known as H1 line. After that, how many arguments are there, and we need to expand or give the brief description about this. See, the here is the input arguments. So very first is amount, loan amount in dollar. Okay, first is amount. Then we have a rate, annual interest rate of the percent in percentage. Okay, this is the rate. And third we have years. Okay, this is the third argument, number of years. Then we have corresponding to this, we have output arguments, and output arguments, these are two. One is monthly payment and second is total payment. So all the parameters which are involving in our function, we can give description about this, and all these lines will be commented with the percentage sign. For this sign is used for comment. And when we comment the statement, that part will never be the part of the program of the function. Okay, so this part is just the description about the program which we are going to write here. Details about the parameters, input arguments and output arguments. After that, this part is function body. This part is function body. So here the complete formula about this function we will describe at its place. So first we are choosing here format as we discussed in the very first lecture. There are several formats, and according to our need, according to our choice, we are using this type of format. After that we have ratum. This is the one part of the formula. Rate, then product 0.01 divide it by 12, and all these three statements are the part of formula. And A is equal to we are choosing here A plus ratum. B is equal to we are choosing here A raised to power years into 12. This will convert year into months, minus 1, and divide it by ratum. This part divided by this one. And the next line we have monthly pay. This line will calculate the monthly payment which we need to pay. So the formula for the same, we get amount, then product A raised to power years into 12, divide it by A product B. And this is the formula to get the total payment. Monthly pay into years into 12. So this will give us the total payment after the year. So and after that we can end the program. Here we need to end. So this is the part of the program, and when we write this program in the MATLAB and we need to save this file, but when you are going to save this file, the name of the script, this function must be this name. Only then we can execute this file, and this file will work for us. So you can note this step, and following this step you can write the program and you can pass these values. I give you one more example here. I am giving you one more simple example. This will be very simple. Now come at this place. Okay, and yes. So here we are writing a program and we want to choose the maximum value. Yes. I have prepared a file, and this file will help you. See what we are doing here. I write a program to get the maximum value from 5 arguments. So here you can see easily these are N1, N2 and N3. These are 5 numbers. And randomly we can assign any value to all these numbers. So N1, N2, N3, N4 and N5, these are 5 numbers. Okay, and I write this program for I have saved this file with the name of my maximum function. I want to get the maximum value from these 5 numbers. Okay, So that's why I have to save this function with the name of my function. And this is the output value I want to get at the end. What will be the maximum value if I have assigned different values to these numbers? And these lines are commented lines, and as you know, this is not the part of the function, not the part of the program, but description about the function. So what we are going to do here, this function will calculate the maximum of the 5 numbers. Okay, so when we will assign different 5 numbers at this place, this will return the maximum value only. So how we can write this program? So there are if I have n1, this is the very first number, maximum is equal to n1 if there is n2 number and n2 number is greater than from this place n1. Okay, if n2 is greater than n1, then maximum will be equal to n2, and we have to close this condition. This is the very first condition. Okay, so now we have the value which is maximum is n2. If there is one more number n3, and suppose that n3 is maximum, n3 is greater than n2. Okay, if n3 is greater than this maximum value, we have to apply the condition again. If n3 is greater than maximum value, okay, this value will be greater than n1 as well as n2. Then we need to print maximum is equal to n3. Keep in mind, note this point very carefully, maximum is the output value. See here on the very first line, this is the statement of the function. See here carefully, each time in each step we are using this value because this is the output value what we need. We need the maximum value. So we are starting from this place, maximum is equal to n1 if we are giving the first value. If there is n2 and n2 is greater than from this maximum value, then there must be maximum is equal to n2 because now n2 is the maximum value. And we end this condition at this place. Now the third part is going to start. If there is n3 number and n3 number is greater than this value, it means n3 is greater than from n1 and as well as n3 is greater than from n2. So we are going to again apply the condition at this place. Note this point very carefully. Okay, so if n3 is greater than maximum, then maximum must be equal to n3. So this is the third part. Again, because there are 2 more numbers, if there is a n4 and n4 is greater than maximum value, which we get at this place. Okay, so if n4 is greater than maximum, then maximum must be equal to n4. So this value will be returned. So this is the fourth part of the body. Okay, and at the end there is also one more number which we are going to assign, and suppose that n5, if n5 is greater than the maximum value which we get in the previous 4 steps, then we have to apply the condition. And note that how we are going to apply the condition. If n5 is greater than a maximum value, then maximum value must be equal to n5, and after that we end the program. So this is the complete body of the function, and this is the very first line of the statement of the function. And note how we are doing all this. Now what we do, we want to test our program. We will open here one new file. Okay, and I want to save this file with the name of Control S, do Control S, and this is the testing. I save this file with the name of testing, okay, and this file will saved in my current directory automatically. You can see the file automatically saved in the current directory. So here you can see there are 5 input arguments. Good evening all of you, and I can see the message from Dennis, Shailash Mishra is there, okay, Jyotsna ma'am, okay, so you are all regular participant in the session. Yeah, Phil Jacob is also there. Good evening all of you. Vani Madhavi, good evening all of you dear participant, and thank you to be part of this session. See now carefully. See carefully. Here are 5 arguments, okay, and we need to test. For testing, I have opened a new file, and these are the arguments which we need to pass. So CLC, then clear, okay. The value of N1, we can randomly assign any value. Suppose it is 13. Then we have the argument N2, and the value of N2 we have is suppose it is 45, and then I have the argument N3. The value of N3 I have is 32. Then I have the argument N4. Suppose the value of N4 is 78. And then we have the value of N5 is, suppose it is 52. Okay. So these are the values of the arguments, but we need to pass this value through this function. We will call this function at this place. We are call this function at this place. Maximum is equal to the same. We have the same function. We are calling this function at this place. Okay. So now what we do, we will execute this script file, and when we will execute, this function will return the value. So I am going to execute. Yes, you can see maximum value is 78. I write this function for small values, just understanding how we can create the function and how we can execute. And you can see clearly here. So see again, this is the N1 value, this is the N2, N3, N4, and N5. And when we pass these values from this function, which we create at this place, so it will return only the one value which is maximum from this. Okay, which is maximum from this. So whenever you will write the function, always save the file with the name of function. Okay, so this name is there in the script file. See this one. So I want to say I saved this file with the name of the function, and the name of the function here is my max function. Also, what about this? Note very carefully. This is the help. This is the help about the function also. You can check here. So when I will do, when I will insert the statement in the command window of the MATLAB, help, then after I will write about the, I will write the name of the function. So what it will return? This will return about the information of the function, which is my max function. I write here, and when I will enter, see what happen. See in the command window, this function will calculate the maximum of the 5 numbers given as input, and this statement is available in the part of at this place. You can see. So all the information which we will give the instructions or description about the function will be the help of the function. Okay, and when we will insert this statement, this will return all the instructions or the description about the function which we will mention at this place. Okay, so in this way, any function which are inbuilt in the MATLAB, and we always use this function help for, if you will write here, help for sine function, and when you will enter, so you can get the detail about the sine function, sine argument in radian, and sine x, sine of the elements of x. Okay, and you can get more detail by using by pressing all these functions which are available here. If you are using a sine, click on it, a sine. This will return more detail about the a sine function. Yes, you can get a sine is inverse sine. Okay, so in this way, help is also a very useful tool. If you need some information or some guidelines, if you don't have the right information, in that case you can take help from the MATLAB. Okay, you got it? Good evening, all of you. Okay, so here is also one more function which is anonymous function. Okay, so what is anonymous function and why it is required? This is the second type of the function which is anonymous. So anonymous function is like an inline function in traditional programming language and defined within the MATLAB, a single MATLAB statement. It consists a single MATLAB expression and any number of input and output we can assign. We can give, we can write a line function or anonymous function for one argument or 2 or 3, whatever we need. And also we can have more outputs. So depends upon our need, which type of function we need, and we will present here some examples for the same also. We can define the anonymous function right at the MATLAB command line or within a function. Note this line very carefully. We can write the function in MATLAB command line within a function or the script. Sometimes we need to write a function in the part of the function. Okay, in the case of nested function. So in that case, we can write this anonymous function and we can use in our program. Whenever we need, we can simply write, and it is very simple to write also. This way can create simple functions without having to create a file for them. And the syntax for the creating the function is, see, this is the syntax. Okay, this is the syntax for the same. F is equal to @ at this place we will give the some arguments, and here is the expression. So anonymous function is the example of a line function. Okay, for example, you can see here This is the anonymous function. I am writing here power is equal to @xn. There are two arguments are required, xn. Okay, x is the argument and n is used for exponent. So here is, you can see, x raised to power n. Okay, but don't forget to use dot at this place. This cap sign is used for exponent, but this is an array. So when you are performing a function in the form of array, in that case we have to use dot cap. This will return the element by element product. Okay, so see, here is very simple inputs we are giving here. So how you will give the input? We will use this one, power, and this is the value of x, and this is the value of n. So when we will execute this statement, when we will execute this file, you can press here, and we have the corresponding result. 7 raised to power 3, we have 343. I gave you one more example, CLC. See here, I am taking f is equal to @. Here is only one variable, x. Then this is x square. Then I have plus 2x. Then plus I have 3. Then I have 3. So this is one line function, and I can easily pass different values through this anonymous function. Okay, f2. So the value of x is equal to will pass through the above function, and this will return us the corresponding value, which is 11. If you have an array, suppose I have an array starting from 0 to with the difference 1 and 5. Okay, I have this array, and we can pass this array through the function y is equal to, I have f then x. When I will enter, see, these are the corresponding values of this array. When we have x is equal to 0, we have 3. When we have x equal to 1, we have 6. When we have x equal to 2, then it is 11. When we have x equal to 3, it is 18. And when we have x equal to 4, then it will be 27. And when we have x equal to 5, then the value of this function we have 38. And this is the very simplest example to use. Yes, some participants are asking about the matter. As you know, we have launched an app. Okay, our foundation has now app, which is the name of the app is MathTech Thinking Foundation. But there is some updates are required. Hopefully, because we are facing the problem from the international participant, they are putting the questions that they are not able to sign in. Very soon it will be sorted out, and the problem is that there is country code. Okay, now there is we are making some changes so that international participant can also do sign in the app, and you can easily sign in by using your email address. in the place of contact number. So the second option will be available very soon. So that's why right now this mobile app is not working. It will take 2 or 3 days after update. Then you can use this mobile app also, and all the lectures, all the activities you can easily access, and this will keep you a regular update. Many things we are going to organize, but due to this technical issue, we are not able to share the link for this app. But many participants, I have shared the link. But please excuse me for this time, only for 2 or 3 days. All the updates will be there, and then after you can use this mobile app for your future use. Thank you. So if you want to write an anonymous function for 3 variable, also you can plot this function. If you want to plot, how you can do? See, I have x is equal to, this is a new argument I am giving here, 0, then I have 0.1 and 5. Okay, this is the argument. Then I have y is equal to f. Y is equal to, I have fx. Okay, y is equal to, I have fx. So f is the same function which we write at this place. Note this carefully. Okay, so y is equal to fx, then enter and plot x comma y. And when we will enter, this is the graph of the above function. You can see here. Okay, so this is the very simple way to write anonymous function. We need required to define anything directly. We can use in one line statement, and we can use it anywhere. Okay, if you have you want to write anonymous function for 2 variable, this is also possible to write anonymous function. See, here is z is equal to @ I am writing the function for 2 variables x comma y. Okay, and here is sine, then x square plus y square. Okay, y square, and suppress it. Semicolon is used for suppress. So I suppressed the statement. You can see I need not required to declare the variables directly. We are using here. Now, if you want to pass the numerical values, you can do, and it is very quite simple. Z 2, 3. I want to check the value when z is equal to 2 and y is equal to 3, and when I will enter, this will return the corresponding value of this function. This function is z is equal to sine x square plus y square. You can check for some more values. Here is 9, then I have 10. Okay, and when I will enter, you can see the corresponding value. If I want to plot this function, so you can do also. I have x comma y, then is equal to mesh grid. Mesh grid. We are choosing mesh grid from 0.02, then I have 5. This is the mesh grid, or you can use for pi. Okay, and semicolon. Then we need to we have f is equal to z xy, x comma y, or you can give here z1. I am using here z1. Okay. Now surface. We are using surface function x then comma y comma z1. When we will enter, you can see here is very a beautiful graph in 3D. We have the graph for 3D. Yes. This is the graph of the sine function in a 3D. You can rotate the function in any direction. Okay. Yes. So this is the very simple way to write anonymous function and simple to use. Further, if again, if you want to insert more statements, you can do also. We want to use here grid on. We are using here grid on, then box on. Okay. You can see now box is on. Okay. So this is a more fine graph we can see. Grids are there. Okay. If you want to write the same program in the script file, you can write here also. See, I am writing the same function in the script file. I am removing this statement. Okay, so I have g is equal to, I am using here g is equal to, I have at the rate x comma y, then sine x square plus y square, x square plus y square. Sunny Slay, good evening, thank you. Jitner Kumar ji, namaskar. So this is the very first function, and then after we are using this next statement. Next statement, we need the inputs. Here is x comma y. Then we are using here mesh grid. Okay, mesh grid for we are using here 0, then colon point 01, and again colon. Here is 10. Okay, so press. Then again we need to pass this value zg. J is function of for two variable x comma y. Then surface x comma y comma z. So note this statement which I write here. This is a very simple program to write. Okay. And the most important thing is the most important thing is that we are not required to save the file with the name of the function. Sometimes when we are writing a function and in the function there is one more function. So in that case, this type of function, line function or anonymous function is required. Okay. So now you can easily execute this statement by pressing F5. Yes. So this is looking like a very dark image. What should we do? We need to increase the increment. Okay, we need to increase this value. See again. Now it is more fine. If you will increase this value, suppose it is 2. We are using 2 in the place of yes. So this is the graph of the sine function. Okay. Previously we were using here pi. So again I am using pi and C. Yes. Now this is the same statement as we used previously. Okay. So this is the graph of the same as we plot in the previously by using the statements in the command window only. Also you can insert here more statements. We can use box on, then grid on, okay. And if you are interested for the X label, Y label, you can insert more statements here for the labels of X axis, Y axis, Z axis and title. Whatever you need, you can do each and everything. See, if you want to increase the size of this one, you can do okay. See, so here you can see X label, grid on, and also we have the box on. So this is a very nice graph you can see here. And if you want to change its position, you can do in any direction. So the purpose of the writing the script is if you want to insert some more information or you want to change the function, you can do. If I want to change the function in the place of sine function, I want to use here exponential function. See. So this is the graph of the exponential function for the same. So it frequently changes the graph. Okay, we need not required to write the whole program again and again. If you are able to write the script files, if you are choosing here cosine function, okay, see, it will return very frequently and you can do numerous experiments by using in this way. So this is the cosine function in the given domain. Okay. If you want to divide this with x plus y, then what happened? We have this graph. Okay. So I am removing this one. If you want to insert here plus the product of x and y. Okay, see 2xy. So now we have this graph. If you want to multiply here one more function with the help of C, I copy this part and then I have product paste at this place, but I have sine function. So according to your choice, your need, you can extend and you can do whatever you want. Okay, there are several type of functions you can choose, and it will take a very less time for examine different type of functions. So I think it is very clear to use anonymous function. Okay. So anonymous function is very clear to all of you. Functions is very clear to all of you. Okay. Now we will discuss about some more anonymous function has been discussed, because the anonymous function is like an inline function in traditional programming and defined within the single MATLAB. Okay, several examples we present here. Now we will discuss about the primary functions and sub functions. What are the primary function and what are the sub functions? Any function which is other than the anonymous function must be defined within a file, and each function file contains a required primary function that appears first and any number of optional sub functions that comes after the primary function and used by it. Sometimes when we are writing a function, I will try to present here example. Suppose I have a function. For example, I want to calculate the root of a quadratic equation. So the main function is quadratic and involving the three parameters, suppose A, B and C. And we know when we want to find out the root of this quadratic equation, then first we need to find out the value of a discriminant. So the discriminant is, again we have a function. So this is the sub part of the main function, and the main function, which is quadratic, is primary function, and other part like discriminant, it is the sub function of the primary. So here I want to present a very simple example. If you have any question, you can put in the chat box and I will try to justify you. Okay. Sane Saleh, thank you very much. You are getting all these things. And from Canada, Solar Academics, when I click on the output, it turned to plain output 2D and 3D. If you can put your complete question, I will try to justify you, Canada. Okay, find them on YouTube. Okay, thank you very much. So now here again, see in the MATLAB, we are going to discuss about primary and sub function. Okay, so I open the script file which I have already prepared. Okay, see in this function, as you know, for the quadratic equation, just 1 minute. Epic pen. Just 1 minute. Where is Epic Pen? Okay. Yes. See here, I have the quadratic equation like ax square plus bx and plus c is equal to 0, and I want to find out the root of this equation. So here only three parameters are there, a, b and c. These are the arguments for any quadratic equation, and I save the function with the name of quadratic, which you can see at this place. When we find out the root of this equation and we know that there will be two roots, say x1 and x2, these are two roots of this equation. So these are the outputs. Okay. So we are writing here the function to find out the root of the quadratic equation, and this is the description about the function what we will going to perform at this place. And there are three inputs required. Okay, three inputs are required. These are the three arguments, which are a, b and c. And these three arguments are the coefficient of x square, then y, then x and constant term. Okay, so see this statement very carefully. A, B, C are the coefficients of x square, x and the constant term. So this is the primary function. The very first statement showing the primary function. Okay, and this is the after that we have D is equal to disk ABC. This is the for discriminant, and x1 is equal to we have minus B plus D divided by 2A, and x2 is equal to we have minus B minus D upon 2A. So discriminant will be equal to this one. Okay. So at this place we end the function. This is the end of the function. But we need also along with the sub function. And see, just 1 minute, I have to remove and close. Yes. So see carefully here, this is another function which is a part of the same function. Okay, and this is the sub function of the primary function. So here we are using the discriminant, but we have to define this function at this place, and only then we can calculate discriminant for the quadratic equation. This is the output. This is the output. Okay, and discriminant, and for that to calculate the discriminant we need three arguments a, b, c. So this is equal to square root of b square minus 4ac, and then end. So this function, sub function starting from this place and end at this place. The primary function, as you can see, the primary function, this is the primary function. Okay, and this is the sub function. So we can divide a function in two parts, and one part will be the primary and the second part will be the sub function. Okay, so now how we can perform? See this script file. we are assigning the value of the arguments, and argument for any quadratic equation we have. Sorry, these are the argument. We need to assign the value of a. Suppose a is equal to 2, b is equal to I have -4, c is equal to I have 5. But I have two values. I have two outputs, x1, x2. So I am writing here x1, x2 is equal to quadratic a, b and c. Here also I am using CLC and clear. Okay. When I will execute this script file, you can see I have two roots of the same equation. The value of x1 is equal to this value, and the value of x2 I have 4 minus 4.899 iota. Both the roots are complex conjugate, you can see. So what is there? We write our function in this file, and this file where we write the function, the name of the function as well as the script file, which we save here with the name with the extension .m. This must be same. The name of the file must be the same as the name of the function. Okay. Only then this file will work, otherwise you will face error. Here you can do numerous experiment. You can change these values. Suppose I have C is equal to 3 and B is equal to I have -9, A is equal to I have 1. Okay, so you can see here are two roots, and both the roots are real and is different also. So by using in this way, you can write numerous type of programs by using in this way. You can break your function, okay, and you can break in several more parts. Sometimes we have a program involving one function, two function, maybe three function, and maybe more than three functions. Okay. So I hope it is very clear to all of you, and still if you have any problem, you can put your question in the chat box. Okay. So now we discuss here one more function, and that is, yes, I am waiting. If you have any question, you can put in the chat box. Can we pass the value of argument directly instead of defining explicitly? Yes, you can pass directly. Okay, you can pass directly the values. See here. Okay. Copy from this place and see. I am assigning the value 3. Here is 4, and it is -2. Okay. So you can pass these values directly in this way also, and you can get two solutions, as you can see. Okay, you can use directly in the command window. Here you can choose when you will press upward arrow sign, and you can change these values. Suppose it is 5, and the last one is 3. Okay, and when I will enter, see I have two roots and both are complex conjugate. Okay, so it's up to you how you want to use or how you want to pass this argument. Okay, so it's no difference whether you are using script file or you want to pass it through the command window directly. It's up to you how you want to use. So now we are going to discuss about one more interesting function, which is nested function. Okay, nested function is also very useful, and it is similar to the previous example as we discussed here. We can define a function within the body of another function. These are called nested function. A nested function contains any or all other component of any other function. Sometimes nested functions are defined within the scope of another function, and they share access to the containing function or workspace. So I want to present here some example for the nested function. I have prepared the code for the same so that I can save the time and maximum examples I can present for you. You can see here is, yes, here is some example of the nested. Okay. Yes, I have these two files. So when you are writing or you are thinking to write a nested function, okay, so here I am presenting the example of nested function by using the handles to store function parameters. Okay, so when we are writing the nested function, three things are required. One is input argument, and second is variable defined within the nested function. And third, most important thing is variables defined in a parent function, also called externally scoped variable. Okay, so these three things must be keep in mind while you are going to write nested function. And I will try to present here very interesting example, and this will be, once it will be clear, then you can use according to your choice. Okay. Yes. So when you create a function handle for nested function, that handles stores not only the name of the function, but also the values of the externally scoped variable. And for example, you can see here is very simple. We are going to write a function for parabola. Okay. So for the parabola, you know, it will be, this will be the, every quadratic equation represent the parabola, and there will be three arguments. So P is the output function, and the name of the function I give at this place, make parabola, and these are the corresponding arguments. So here what we are doing, we are using here handle function with the help of anonymous function. You can see P is equal to @ is used to handle the function, and by using @ we can write inline function, anonymous function. Okay, so we are handle the function by using @. So P is equal to @ parabola. Now we are writing the function for parabola. Here is the function. Here is the part of this parabola. So function y is equal to parabola, and there is only one argument. Okay, y is equal to, this is the function, y is equal to ax square plus bx and plus c. So a, b, c are the arguments which we give at this place, and this small function or sub function has been written at this place, and then end the function. So when a function contain one more function or sub functions, at this place we have only one sub function, there may be more than one sub functions. Okay, so it depends upon our problem how many sub functions are there, and when we have a function and this type of complete sub function, so this type of function are known as you can say nested function. A function contain one more function. Okay, so this function is complete at this place, and the main function is end at this place. This is the now complete function. Now what we do, or what we are going to do, see here I tried to put all the details how we can use. Okay, and I think the text which I provide here are very clear to all of you, and all these are readable. So see this very first statement. The make parabola function returns a handle to the parabola function that include values for the coefficient of a, b, and c, and at the command line call the make function parabola, and we need to assign the values of the parameters of a, b, c. This is the value of a, this is the value of b, and this is the third value c. Okay, and use the returned function which handle the p to evaluate the polynomial at the particular point. See here, p is equal to, what this will do, this will calculate or pass the values of a, b, and c. Then we have a polynomial whose coefficient will be, these values will pass through at this place. C. At this place the values will pass. Okay, and we get the polynomial in x. So we have the polynomial y is equal to, the at the place of value a we have 1.3, and at the place of b we have 0.2, and at the place of c there is 30 in this. So when you will pass these values, we have a polynomial. This is a polynomial. Okay, and when we assign the value x is equal to 25, this will return, see here, I am copying this statement in my command window, okay, so that I can justify you. See what happened. CLC, I am using this statement, okay. Now I have x is equal to, assign any value 25 and then enter. Okay, and y is equal to, I have p. P is the polynomial, and we want to pass this value through the, sorry, here is x. Okay, And when I will enter, this is the value of y when x is equal to 25 and value of a is 1.3, value of b is 0.2 and value of c is 30. Okay, or you can pass this value directly. This is 554. Again, if you want to plot, this graph, you can do. Okay, so for the plotting, we are using fplot. We are using function plot function. This will plot the graph, and this is the function p. P is this polynomial. P is this polynomial, and we want to plot in the range minus 25 to 25. Copy this place and paste here in the command window, and when I will enter, you can see this is the graph of the parabola in the range of minus 25 to 25. Okay, I think Jatinder Kumar ji, you are asking this program for only quadratic or others. The thing is, we can write many programs according to your choice. You can write more programs also. But here I am presenting here simple examples so that we can write all this. Okay, if you have any cubic polynomial, you can write the program for the cubic also. I will give you more example, whether it is a cubic or a biquadratic, any kind of function you have, you can do for each. Okay, so yes. Okay. So the thing is, I was talking about the plot. Okay. Also, we can create multiple handle to the parabola function that use different polynomials coefficient. Okay, you can see here are some statements. This is the first statement. Make parabola, and here you can see these are the values of a, b, c. These are different values, and this is the second statement. And in the second statement, we have the same function. We have the function is same, but values are different. And we are choosing here range. This is the range. Range is from minus 25 to 25. Then Control T. Okay. Yes. See now carefully. We have a figure, then hold on, because we have now two functions and we want to plot these two functions in the single image, in the single graph. So we will use, we will take the help of hold on and hold off. So this will return the plot of this function. This is the first plot. Okay. The information on the right hand side saved in at this place first P, and this is the second P, and second P plot will be at this place. So this is the second P, and then we pass the range, this one. Either you can use this range at this place directly, or you can assign the range to any argument. Okay, then you can use that argument. And this R, this is the marker for the second graph. When I will execute this sequence of statement, so when we will use this sequence of statement, and I can run this file, yes, you can see. we have two graphs in the same file. One is in the red color, this is the second image. One is in the blue color, this is the first parabola. These are two parabolas in the same file, and we can do. Okay. So if you want to write any more function, I am copying this statement and see what I am doing. I am using here cubic. Make cubic. I am using here cubic polynomial. Okay. And there will be 4 coefficients. I am using here cubic. And here is also cubic. Okay. So now we have x cube. Then we have bx square. Then we have cx. And then we have d. Now when I will save this file, Control S. See, the name of the file must be same as the name of the function. Okay. Now what we do? We will do all these things as we do previously. Okay. So you will create one more file. So yes, this is the numerical. Save this file with the name of numeric or cubic. Okay. Or either you can use it directly. There is no difference. But here we want to calculate this one. Now assign the values of A, B and C. The value of A is 2. The value of B we have is 7. The value of C is 1. The value of D is -5. Okay. These are the just coefficients of x cube, x square, x and constant term. Okay. So when you will run this file, what is the meaning of this one? This will generate a cubic polynomial whose coefficient will be 2, 7, 1 and -5. Okay. So when you will assign x is equal to 25 or x is equal to 2, then you will pass through this value cubic polynomial. Okay. When you will execute, once again, yes, this is the 41. So when you have this cubic and whose coefficient are 2, 7, 1, -5, and when you will pass x is equal to 2, then you have 41. You can change this value. Okay. And again you can check it. This will give us 685, and if you have x equal to 0, then it is -5. When we have x equal to 0, it means only constant term. Here is -5. This is the constant term. And here is -5. Okay. If you want to plot, you can plot this image also in the same way as you do at this place. By using the same statement, you can plot here. Yes, in the range of -25 to 25. see the graph of this cubic. Okay, so there is no difference. Whatever you have, you can do all type of experiment. Can you please shed more light on the use of character at the rate? Okay. Okay, I will repeat the same. No problem. So I think it is very clear. Whatever you have the function, you can write your own functions. Okay. Whatever you need, or what is your requirement, according to that you can break the statement, you can write your own functions, you can manipulate them, you can call them, you can use anywhere for your own purpose. Okay, so now I want to clear all these statement, and there is one more last function which I need to discuss with you. Nested function has been discussed, and there is a private functions. Okay, we can create the private functions, and we can save the file, and we can call the private function anywhere. But the thing is, a private function is a primary function that is visible only to the limited group of other functions, because this is not the part of the script file, but we can write several private functions, and we can save them in a single folder. If you don't want to expose the implementation of the functions, you can create them as a private function. Sometimes it is required, or you can see in the MATLAB all the functions are inbuilt function, and sometimes if we don't want to show, then we can write our private function and we can call them according to our need. I will try to give you some more example, and I'm sure this will help you to understand the concept. And private function reside in the subfolders with special name. You can give privately. They are visible only to the functions in the parent folder. Where you save the files, only there these functions will be available. Here I want to present one more example for the private functions. And you can see my desktop, and here is the folder, and this is the folder where I create yes, I want to open, and this file and this file. Okay, so here I have opened 3 files. See very carefully all these files, and I hope it will be very clear to all of you. We know when we are thinking about to find out the roots of a quadratic equation. So quadratic equation is one part of the function, and to find out the roots we need also the discriminant. So what we are doing here, we write a discriminant function privately here in another file, and this is the same as we use as a sub function, but here we don't want to show about this function, we want to hide this part. That's why I create this function privately, and this is the program to find out the solution of the quadratic equation. Okay, see in this file, we know, as we discussed in the very previous example, to find out the root of a quadratic equation. Yes, as you know, we are talking more about quadratic equations, but not necessarily that you can write only for the quadratic. We can write any type of function, but the thing is which you need to understand how we can break the function, how we can write the function, what is the meaning of the private function, what is the meaning of the nested function. Okay, so similar examples I tried to present here so that the concept which you need to understand must be very clear. Once the concept is very clear, then you can use for different type of problems. Okay. So the most important thing which you need to understand here is this is our function to find out the root of the quadratic equation. Okay. So we know there will be two roots. One is x1 and x2 for the quadratic, and the a, b, c are the main argument which will involve in the quadratic equation. Okay. And three arguments are required. X, a, b, c will be the coefficient of x square, x, and the constant term. Okay. And what is d? D is equal to, we have discriminant a, b, c, because we write this function privately in the another file, and we are calling this function in this program. Okay. We are calling this function in our main program. Okay. So D is equal to, we have discriminant A, B, C, and x1 will be equal to this one, and this is the x2. And then end. Then we end at this place. Also, you can create private functions for the x1 and x2. Okay, then you have three private functions, and you can then after call these three functions at its place. So it depends upon our choice what type of the function we have and how we want to use them. I will show you some more examples. This will be very interesting for all you. Okay, so here is the problem we have same, but we are dealing with it with different way. Okay, see once again, this is the main function line, and then what we are doing here, D is equal to discriminant, and we write the discriminant function privately at this place, but we are calling at this place, and x1 will be equal to this one, and x2 is given by this one, and the function. So this is the very simple function. And here is the use of the same. You can assign the value, or you can pass these values through the function directly. Okay, but I write here a script file. When you will execute, you can see there are two roots, x1 and x2. Both are complex conjugate. Okay, or either you can use CLC. Either you can use it directly, this statement, and you can pass the values. Suppose the value of A I have is 2, the value of B I have is -3, and value of C is 5. Okay, and when I will execute, yes, I have complex conjugate two roots. Yes, you can see. Okay, and also if you want to calculate the discriminant value, you can find out the discriminant also. See, D is equal to, I have, yes, if you put these values, the coefficient, the value of A I have is 2, value of B is 3, and value of C is -5. This is the discriminant, which is 7. Okay. So in this way, we can use these functions. This is one function, this is the another function, but we are calling this function in the at this place. So this is all about the functions, and various examples are there, and one more function is there, global variable. Yes, global variable. We are talking about global variable. Okay. So first I let you know what about the global variable. Okay. What you know about the global variable? This is very important to know first. Global variable can be shared by more than one function, and we need to declare the variable as a global in all the functions. If you want to access that variable from the base workspace, then declare the variable at the command line. The global declaration must occur before the variable is actually used in the function, and it is good practice to use capital letters for the names of the global variable to distinguish them from other variables. Okay, so you can see here I am presenting here some very simple example. We want to calculate the average of the numbers. Okay, average of the numbers. So this is the first line of the function, and then we have global variable, which is total. Okay, the global variable always will be declared in the uppercase letters. Use always capital letters. Okay, and here is the formula. Average is equal to, this is the sum function, and all the numbers will be added, and then we will divide by the global variable, which is total. Okay, so this will give us the average. So how we can use this function to find out the average? But here total is global variable, keep in mind. Now see, first we are using the global total. You can use in the command window, you can use everywhere where you want to use. Global variable is total. Okay, this is the very first statement, and we want to assign that we have the total global variables are 10, and these are the numbers. These are the numbers which we want to pass, or for which we want to find out the average for these numbers. And numbers are n equal to, we have 34, 45, 25, 45, 33, 19, 40, 34, 38, 42. Okay. And now we want to use this function. We want to use this function. This value, this is the argument. This is the argument for this function. Okay. So AB will give us average of the above numbers, and when we will run this code, either you can run this code in the script file, you can run this code in the command window. There is no difference. So when I will press, this will give us the average of these numbers, and these numbers are 10. Total are 10. So we assign 10 values. Okay, if you have this one is 145, then this value 145, all the values are 3-digit. Okay, I am changing all these values. So when I will execute this code, the average of this number will be this one, 405.5000. Okay. So Neil Pong. Okay, there is no issue if you are joining late. Okay, you can restart this lecture, and I hope the content which I tried to present here are very helpful for all of you. This is all about the present lecture. If you have any question, you can put in the chat box so that I can check it. Sorry. Yes, you can put your questions in the chat box. Good day, Bola Jatinder Kumar ji. Okay. So I think the lecture is very quite simple, and once again I want to repeat what I present in this session very frequently. So the one question was about the Jatinder Singh, there is no return statement. Jatinder Singh, can you put your question clearly so that I can, I don't get your statement. There is no return statement. I don't get your question. CLC. So one participant was asking about the use of this line function, inline function. Okay, this is very quite simple to use. So inline function and we handle by using @ if the function is of two variable x comma y, okay, then you can choose any statement. Suppose it is x cube plus y cube okay, and plus I have 3 product x product y. Okay, so this is the function, and now you can easily pass the values z. So all the information stored in z. Okay, so you will pass these values from this place, and when you will enter, you have the value, corresponding result for particular values of x and y. And if you want to plot this function, you can do also. How you can do? First, you need to choose mesh grid. X comma y is equal to, we have mesh grid. Okay, and I am choosing the mesh grid from 0, then 0.01 up to 10. Okay, then z is equal to, sorry, f is equal to z. I can use here x comma y, x comma y. Then surface x comma y comma f. Okay, and this is a surface. You can see here. You can see the surface. My MATLAB shutdown. Okay, it is opening. At the rate we are using, Canada is asking what is the use of at the rate. See, at the rate is just used to declare the variables, how many variables you are choosing. Okay. See once again, if I have f is equal to at the rate. Okay, I am choosing only one variable. At the rate is used how many variables or parameters you are choosing for your function. Okay, so here is, now I am choosing only one variable at the rate, function for at the rate x variable only. Okay, x square, then plus 2x, then plus 3. Okay, and when I will pass any value, because now there is only one variable. Okay, so at the rate is used for to handle the function, and also the variable which we are using, and this is the function. Okay, and this is the argument, and this is the function. So when I will enter this statement F3, see, so this 3 pass through this equation, which is x square plus 2x plus 3. So when you will put this value in the polynomial, it will be equal to 18. If now we have this is very simple function, f is equal to, we have x square plus 2x plus 3. Okay, now we have, this is the function. If you have any function, suppose you want to write a function for x square plus 2x plus 3, okay, and plus cosine x. So the way to write this function is f is equal to at the rate, and right hand side there is only one variable x. Then first function we have is sine. So this will be this one, then 2x, then plus 3, and product, sorry, here is plus sign. Okay, then we have plus cosine x. So this is the whole function, and if you want to write a function in line, or you want to declare anonymous function, then you can do in this way. Okay, so the use only for the variable. If you want to a two variable function, then you will use in this way. I have x comma y. Okay, and sine, you can take here x square. I am choosing here x cube plus y cube, and plus 3 product x product y. I have this function. So you can see function handle value. This is the function which we want to handle. J is handling this function. Okay. So now you can check the values. You can pass any particular values for x and y. I want to pass 2 and 7, and we have this corresponding value. Okay, so in this way you can easily use all these functions for one variable, two variable, three variable, and involving more parameters also. If we there is one more question, what is the difference between float and f float? When you are using No difference big, but sometimes if you have function and you want to plot the same, the main difference is in the use, because there are several functions for the plotting. According to need, we can use them. See here, if I have inline function, okay, and I want to plot this one, then I need not required mesh plot. I can do directly. I have to mention only the range. See this very first function, f plot, then I have f comma, this is the range, minus 5 comma 5. Okay. Yes, you can see the graph. And the another way, if you want to plot this one, you need many things. See, the another way, if I have x is equal to minus 5 point minus 5.1, then 5. Okay. Then I have then I need y is equal to f x. Okay. Then I can use plot. X comma y. We have the same graph. But the difference you can see here, I have to follow each step. Okay. See, I have x is equal to, this is the range which I assigned here, and also I need to assign here the increment which we need, otherwise this will not be possible. And y is equal to fx is also required because x argument must pass through the function. When we have x and y vectors, only then we can plot this one. But in the case of this statement, f function we can use directly. Okay, we can use directly to plot the graph. So this depends upon the use, how we want to use all these statements. Okay. So dear participant, thank you very much to attend this lecture till the end, and I hope all the lectures which we are presenting, the content are very helpful, very supportive, very informative for all of you. Your feedback is very important for us, and also I would like to inform you that the feedback link is available in the description of the this channel. On each lecture, when you will go to the description, you can easily find out the feedback link, and you can submit your feedback for all the lectures there, so that this will maintain your attendance also. And at the end, when you have more than 50% attendance of these lectures, you will have the certificate of participation of this series also. Okay. And as I inform you that mobile app is also ready, but need some update because international participants are not able to join the same. So this will be sorted out within 2 or 3 days, and after that international participant will also be able to sign in, and all the things, all the events which we are organizing, you can check all the information through this mobile app. This will keep you update about all the activities which we are organizing for the students also, and faculty members are also there. and it also help you to submit your feedback to communicate with us directly. Many features are there in this mobile app, and you can easily download this mobile app by using the name of the foundation, MathTech Thinking Foundation. Your feedback is very important for us, so please submit your feedback for each day. And if you have any question, you can put your questions in the feedback form, and we will try to cover your questions in the coming sessions. Thank you very much to see this lecture till the end. Have a nice day. Good night.